In this video, we're going to do some practice problems relating to word and skeleton equations. The answer keys can be found here, or you can watch the video to make sure you understand the concept as well. So we'll start with this first problem here. You should always try the problem yourself first, then come and see the video to assess yourself. When aqueous beryllium chloride reacts with aqueous silver nitrate in water, aqueous beryllium nitrate and silver chloride powder are made. So first we're going to identify our reactants and our products. So we're told that beryllium chloride is reacting with silver nitrate. That's a key indication that those are the reactants. They're reacting together. And silver nitrate. We're told that what's made is beryllium nitrate. So it says when aqueous beryllium nitrate and silver chloride are made. So beryllium nitrate and silver chloride are your products. So now we have to make our word equation. So we're simply going to do the reactants, beryllium chloride plus silver nitrate. I'm just going to make the arrow down here so I have enough room to write everything. Gives you beryllium nitrate. Again, this is why word equations are not as convenient as skeleton equations. Beryllium nitrate plus silver chloride. Then I'll write a skeleton equation. So beryllium chloride with crisscross would be BeCl2. And it says aqueous, so it's aqueous reacting with silver nitrate. So silver nitrate's also aqueous. So silver's +1, nitrate is -1, so AgNO3, also aqueous here it says. And then it says that aqueous beryllium nitrate are made, so BeNO3, 2 with your crisscross, right? Because it's a polyatomic ion, it's aqueous. But then it says that silver chloride powder is made. And so silver chloride is with your crisscross AgNO3, but it's powder, which means it's solid, like that. So then that would actually help you with the next question. It says, what evidence of chemical change was seen? Well, look at the question. It says a powder was made, a solid was made. So we know that the evidence of chemical change was a precipitate. So don't try to make any other guesses right now. Just go with the precipitate because that's what's told in your scenario. So that's how these problems are typically approached. It does require you to have knowledge of the previous stuff we did. And of reactants and products and equations, but also of all the naming rules. So try the next one, pause it and try it yourself, and then unpause it and let's take a look. So at this point, you're just checking your work. We have liquid isopropanol reacting with oxygen gas, carbon dioxide gas, and water vapor. When isopropanol reacts with oxygen, so say I read too fast, carbon dioxide gas, water vapor, and heat are produced. So you'll see that these two are reacting and these are being produced, right? So sometimes you have to read it slowly and carefully. So our reactants are, and you can write it any way, you can write it in words or in formulas. So C3H8O, and it says oxygen gas. So I'm just writing it in the formula form right now just because it's easier for me. Remember, oxygen's a Hofbrinkel, so O2. And in the products, it says that carbon dioxide is made, CO2. Again, you could have just written it with words here, there's no big deal. Water vapor, so H2O. And then heat as well. So heat is not chemical, it's energy being released or transferred. Let's start with the word equation now. So we know we have isopropanol. Now, I didn't teach you how to name things like isopropanol, but that's why I gave you the formula in brackets for later. Plus oxygen, don't put any states, produces carbon dioxide, don't put any states, so water. And you don't have to write heat, you can write heat, you can also write energy as well. So plus heat or energy. Energy is usually what we write down. So now the skeleton equation, we have C3H8O in its liquid form, reacting with, don't forget, it's Hofbrinkel, so oxygen gas, and it's going to produce, it says carbon dioxide gas, CO2 gas, plus water vapor, so also gas, plus energy. And that's it. So that's our skeleton equation. And if I asked you what the evidence chemical change was here, well, maybe you could say change in energy, change in temperature, right? Maybe there was some heat released. Okay, so we're going to try our third problem here. So try it yourself first, then pause the video, try it yourself first, and unpause and check your work. So now you're checking your work. During a collision, a sensor in the airbag detects that the vehicle has slowed down suddenly. In response, a small pellet of solid sodium azide is heated, producing nitrogen gas and some sodium. So we only have one product here. It looks like you just have sodium, or one reactant, sodium azide. That's what you're starting off with. Now, some students might also say, you know what, there's also heat. So we can write heat. It's not really a reactant, but it is helping a reaction. Okay, so I'll just put that like this. It's not really a reactant, but it's helping the reaction. And we're told what's produced is nitrogen gas, so nitrogen, and also some sodium. So we can write a word equation out. We have sodium azide you can write plus energy. You could also do this, an arrow, and then put heat on top here like that. And we're told it makes nitrogen plus sodium. So now we can convert this into a skeleton equation. We're told that sodium azide is a polyatomic ion N3 with a minus on top. So if I want to make sodium azide, that would be Na plus 1, N3, that's my polyatomic ion, with a minus 1. Crisscross it, you would get NaN3, like that. They'd have ones, and then you can just drop them. And so it says that it's a small pellet of solid sodium azide. I'll put heat back here. And it says that nitrogen gas is made, so that's one of our Hofwinkels, right? N2 gas plus solid sodium, Na solid. So this one, the only tricky part was that there was a polyatomic ion you'd never seen before, but you have to apply your knowledge and learn how to crisscross it. That's what you have to understand with science, or really with anything you study or do in life. You know, you learn about it in a textbook or in a video. You see an example, and other examples will be worded differently, right? And you can't be thrown off. The more variety you get in your questions, the more you'll be comfortable attempting a problem when it looks slightly different, right? And the example I always give is, if I say tomato and you're used to hearing tomato, and then one day someone says tomato, you're not going to freak out and say you don't know what that is. You know they mean tomato, right? So it's sort of, that's how different problems should be approached. Like, you've been used to hearing tomato in your problems, and then you heard tomato once, and it doesn't throw it all away. It's still the same skills and concepts. So don't be afraid when you see something a little bit different. You're still applying the same skills. So in this video, we did some practice problems for part 1. In the next video, we're going to do some practice problems for part 2. Once again, answer keys are provided that you can check without the videos if you like.